Okay, now we're going to go on and study another aspect of transformation, which is the inside adding and subtracting. And you may recall from quadratic equations and polynomials, if you have like a quadratic equation, we're seeing the parent curve, and then if we graph x plus 2, you might recall what happens to that. What kind of transformation is it? Well, the inside change is a horizontal shift. So it is going to shift, and which way? And there's this kind of opposite thing going on, but it is going to go left. And that's what we see here when we graph it. It winds up on the left side. So the entire thing shifted left. And then, of course, on the other one, we've got the subtraction going on there. So it's like a question. It's going to shift left or right. But with the subtraction, it always does the opposite kind of thing. So it's going over to the right. So this parent is going to move over to the right 3 spaces. And we're going to see, yep, that's exactly how it graphed. Everything got shifted over 3 spaces. Well, it does exactly the same thing in trigonometry. Except the only difference is we have a periodic wave that repeats itself. So technically, this wave is going to keep going and goes back. And so when it shifts, the whole wave shifts. So in order to kind of help you concentrate on it, you should pick one point to get you started. And for sine, one really nice point to study is the point on the origin. And because if one point shifts, they all shift. So let's study that origin point and see where it goes. Now, in class, we'd have a discussion, make a prediction, but it is a plus, and it's a pi force. Which way is it going to shift? And if you recall from horizontal shifts, when we're adding, it winds up with the effect of shifting it left. So after some discussion in class, you'd probably all be agreeing that, oh, it's going to go to the left, and it's going to shift over here to this value of negative pi force. And so some people might debate that, and we'd have a discussion, and then we'd look and see what happened, and we graph, and it actually did shift it to the left, and it landed right where this value was, pi force, except it was on the negative side. And then on the other problem, the next one, we have a minus pi halves, and when we think about horizontal shifts, oh yeah, that's going to go to the right side. So a lot of people are predicting that this graph is going to move to the right. So the whole graph moves, but it's nice to look at one point. So if we can track one point, then the whole graph is going to follow. All the points are going to shift. So one good point for cosine is the point 0, 1, because we're still on the y-axis, and we're going to shift off the y-axis. And so a lot of people would predict, okay, this one is going to shift to this value right here, pi halves. Before we do it, though, there's another transformation, the 2, and what does that affect? Well, that's an outside multiplication, which is a vertical stretch. So we should see this point stretched up, and this point stretched down, but it's also all going to get shifted as well. Let's see. But I'm concentrating on the shift. That's the thing I really want to test. And when we graph it, sure enough, it did shift over to the right pi halves. So if there is a function that has y equals sine of x minus c, it's very straightforward. This c is a horizontal shift, and it tells us exactly where we're going to go. In this case, on that right side problem, c was pi halves. And in this case, c is pi fourths. Okay, now I'm intentionally creating an oversimplified problem. And now I want to look at the situation when it's not simple. And I have a new equation for you. Let's study this next one. And if you look at it, you'll see something's different. Okay, we've got, oh, that's different. -3, but that's a vertical stretch and a reflection. So the outside multiplication is pretty straightforward. And oh, here's c, negative pi halves. And so my question to you is, this next one, is it going to shift like the one before? Because the one before had negative pi halves, so this one too. It's going to shift over to the right to the number. No, I wrote that wrong. The c number was pi halves. It's going to shift over to the right to pi halves. Is that where it's going to land? And we might have a discussion about that, and then we would graph it and see, yeah, probably should, because that's the number. And when we graph it, it's like, wait, a lot of things are weird here. It's way different than the one before. First weird thing is it landed here. I mean, it started here. And that is the number pi fourths. And pi fourths is nowhere in this equation. The next weird thing is it has 2 cycles. I have a cycle here and a second cycle here. Okay, now actually the 2 cycles isn't so much of a surprise because b is 2. And we should have 2 cycles. And since b is 2, we should also have shorter cycles. And if we actually study this, we can figure out their periods are shorter. We can see that, but we can also see exactly what the cycle lengths are. But I'm not worried about the cycles. I want to concentrate on the shifts. What's up with that? It did not shift according to this number that we had here. So the shift is affected by the b. B had an influence on the shift. So that wasn't our shift. If we want to compare these 2 equations, we have to realize what made these first 2 nice. They were easy shifts here because x was by itself and x was by itself. If you have x by itself, then you've got the shift number. That will be your horizontal shift. But this one, x is not by itself because I have 2x here. However, if we factor the 2 out, then we will get x by itself. So 2x divided by 2 is x. So I factored out the 2. Now I have to factor out 2 from negative pi halves. Well, it'll still be negative, but factoring out 2 is like pi halves divided by 2, which is pi halves, times the reciprocal, which is pi fourths. All right, well, pi fourths, I recognize that number because that is the number of where the graph actually shifted to. So if x is by itself in this factored form, then the number inside the factoring is going to be your shift. Okay, so what we did with these few experiments here was to start to create a little bit of intuition and a little bit of understanding, but something went on here with division. There was a divide. So we're going to come after this this phase shift or the horizontal shift 2 ways. One way is a factoring way, and one way is with formula. I'm going to give you a little formula here. And the formula has to do with dividing those two numbers. So let's see. I'm going to formalize it over here on this page. Let's summarize, and while I'm summarizing, I'm going to formalize this idea of the shift. So first of all, when we're looking at an equation, let's say we're looking at y equals a cosine, it could be sine, a cosine bx plus c plus d. Okay, so of course a is the amplitude. However, whatever, I said that wrong. A is not the amplitude. Amplitude is always positive and a is sometimes negative. So amplitude is always the absolute value of a. The period is going to follow this formula, 2 pi divided by b. The midline equation is always going to be y equals d. Now, the horizontal shift. We have two scenarios that we want to think about with the horizontal shift. C is not the horizontal shift. Not horizontal shift. If you have B, B influences the C, which I said that wrong. B influences the shift. So if there's a B number, the shift gets messed up. So we don't have the shift right away. But I'm going to give you a formula for the horizontal shift. Now it's also called the phase shift. So sometimes you will see it referred to as phase shift. And the formula is negative C over B. When we factored, that's basically what we did. We factored the C by dividing by B, and it winds up on the other side. So if C is negative, the shift will go to the right side. So I really want a positive start value. If C is positive, say we had 2x plus pi. Well, that shifts to the left, which means I'm going to have a negative start value. And that gets a little crazy for people who have dyslexia. So this formula will take care of it, and it will tell you if you put the negative on it, then it will automatically give you the right starting number. If you got a negative answer, you'll be on the left. If you got a positive answer, you'll be on the right. So that's one approach, is just to use that little formula. It'll give you the phase shift. Another approach is to factor. And so if you can change the equation into factored form, A equals A times cosine of B, but we're going to factor the B number off of the X. And whatever number is the C, we're going to factor it out by B. Well, that's really the same as dividing, but it is going to change that number. And then the phase shift will be H. So sometimes you'll see the blue way in Newton. When Newton homework is describing and explaining answers, a lot of times they'll go with this approach. But, that can be a real hassle. If you're factoring fractions of pi, the blue way may be a little weird for you. And, if you don't have a factor, you just have a B number and a C number, then dividing can be really fast and you're done and you know the shift. So I'm going to put it up here as a formula, negative C over B. That's the main formula, but it might be H. Now it's only H if B is factored out. and that's if b is factored. That's kind of complicated, I'm sorry. I think for me, to keep it simple, I'm going to focus mostly on this little formula here, and we'll run with it that way. All right, let's practice. So we're asked for several things here. We're asked for the amplitude, the period, the horizontal shift, and the starting and the ending number. So we got several things to pull out, and they all come from the different parameters. So as I look at this equation, I need to know all the parameters. I have an a, it equals -1. I have a b, it equals 2, and I have a c, and equals -π3. Now this is not factored. It's not factored. So I can't really use the blue approach unless I want to factor the 2 out. But I think it's going to be a lot faster for us just to use this formula here. But let's take off. We've got the amplitude. Okay, so amplitude equals 1. So don't put the negative on it. Amplitude is always positive. However, it's good to remember that there will be a reflection. We've got the period. Okay, the period we're going to have to work for a little bit, because none of these numbers, the ABC numbers, tell us the period. None of those numbers are the period, but we can use the b to find the period if we go 2 pi over b, which is 2 pi, divided by 2, which is pi. So the period is pi. That wasn't too involved. Next, the horizontal shift. But we have a little formula for it. Now we already know this is going to start on the right. Because of the negative, we know it shifts right. And so I need a starting number on the right side. Well, watch what happens here. Negative c over b is negative of -π3 divided by b, which is 2. So that's going to be a negative of a negative is positive π3 times. Now if you divide by 2, that's timesing by the reciprocal. So my starting number is π6. This is where it shifts to for my first starting point. So I'm going to take the y-axis start point and shift it over to the π6 starting point. The last little thing that we want to take care of is the starting and the ending. I'm going to erase some of this here. Normally when we would graph our trig function. We'd have a box, and it would start here on the axis, and it would end here. And like this problem says, it would go from 0 to pi. Let's use a different color here. 0 to pi. Okay, so that would be the normal starting on a graph, except there's a shift. So the whole box has to shift. So I have to move the box π6, which means the end of the box. Normally it would end at pi. It would start and end. But now I have to take the end and move the end to π6 more. So it's going to end here. So that's pi plus π6. When I shift the end of the period over, I'm going to be ending at 7 π6. So the new box is going to be here. it's gotten shifted over. It has a new start and a new end. So the start we already have. That's the shift, pi sixths. The end is going to equal the period, whatever the period is, because that would be the length of the box plus the new starting point is going to shift it over. In this case, it would be pi plus pi sixths, which equals 7 pi over 6. So there we took care of all the details. So this is very analytical what we're doing, really taking these equations apart, and we're really analyzing every little aspect of these critical issues in the equation. But if we can do this, then we can graph these. And you can be much smarter than your calculator after you're able to do this analysis, because you can graph a sketch. All right, but let's also practice writing equations. I have a few graphs here, and I want to write equations of these graphs. Now, similar to writing equations is similar to graphing. When we're graphing, basically we need the equation and we got to get all this information. Well, we got all that information from a box. And the same is true with these guys. We need a box. A box that has a window capturing one complete cycle. Now, we could make all kinds of boxes as long as we have a complete cycle. I could make a box like this. And so that would be a box around one complete. I have a start and an end and a complete cycle. And that equation, I could make the equation for that box. But that equation has a horizontal shift. It went back to the left. And that would make the equation more complicated. It wouldn't be wrong, it would just be more work. So when we can, if we can, it's strategically better to find a box on the y-axis, which is easy here and here. I've got the beginnings of a box. So it tops out here and it tops out again, and I have a complete cycle. So this box is going to be a lot easier to study, to calculate, and make its equation. Now, in general, the box doesn't give us the B's and the C's. Kind of indirectly, A and D come up really fast, but not B and C. But the box does tell us things that we want to record. So, let's pull out one more fact about the box. We need the midline. Well, if we go from -4 to 2, that's 6 spaces, so the amplitude has to be 3. So the midline is cutting right through here. Notice how I'm starting with the midline. That's a really good thing to start with both ways, writing equations or graphs. There's my midline. Next, I want the amplitude. Well, I can pull that off because I know the midline. So the amplitude has to equal 3. The next thing that's easy to pull off the graph is the period, especially because I'm starting here. I'm starting at x equals 0, and I'm ending at x equals pi. So I have an easy start and end, so the period is pi. Next, is there a vertical shift? Well, of course there's a vertical shift because the midline was shifted down. So the vertical shift is 1. And then lastly, do I have a phase shift or horizontal shift? Now that was the advantage of starting on the y-axis. Since I'm starting on the y-axis, there is no phase shift, no vertical shift. And that means my equation work is going to be a lot easier. All right, so we're going to need to write one more thing. What wave do I have? Is that a sine wave or a cosine wave? And since we're starting at the top of the box, hopefully you recognize that's a cosine. And that will define my equation. Okay, so here's what I'm looking for. This is going to have to be y equals a cosine bx plus c plus d. I've got to find all these different numbers, the a, b, c, d parameters. Okay, now d is easy. D has to equal 1. Because of the vertical shift, I've got d, -1. That one's done. Amplitude. That's pretty straightforward too, unless there's a reflection involved, which there isn't. So we've got a. A has to equal 2. So we're done with those two. We still have to figure out b and c, and that's going to involve a little bit of algebra. B is not shown in the box. C is not shown in the box. The only way we get those is by formulas. So I need a formula. I'm going to put the formula for period over here. Period equals pi, which is 2 pi over b. And so we've got to solve this guy. There's lots of ways you can solve it intuitively. Some of you could probably solve this pretty fast, but I find some students solve it too fast, and when there's fractions involved, they get their fractions mixed up. And it's a shame to get it wrong because of a fraction error. But if we divide by pi, we will find that b equals 2. So b equals 2. Okay, we got one more thing. And the last thing is the C number. Okay, well, C is involved in the phase shift. Phase shift equals -c over b. And for this problem, phase shift is 0. Now with harder problems, this is going to be more important. But in this problem, it's not too hard. We've got b, we plug it in. So -c over 2 equals 0. And if you solve that, we're going to find that c equals 0. So now we've got all 4 parameters. So we can just plug in everything. Y equals 2 cosine. B is 2x. C, we don't need a c. And d is -1. And that is the equation of the first graph.